Good afternoon, TechNation. Thank you all for participating in today's webinar. We are thrilled with the fantastic turnout today with over 450 attendees registered. A few notes before we begin. Earlier today, registrants were emailed a Webinar Wednesday workbook. If you did not receive a copy, you can download one now by visiting www.onetechnation.com/webinars and clicking on today's presentation. During today's webinar, all lines will be muted, but you can submit questions during the presentation by using the questions feature on the dashboard on the right-hand side of the screen. If you're having any difficulty, please email us at webinar@mdpublishing.com. Today's webinar is eligible for 0.1 CE credits from the ICC. To obtain your certificate of attendance, you must complete the post-webinar survey at the conclusion of today's presentation. The survey will appear immediately on your computer screen. If you do not receive the survey, please email us at webinar@mdpublishing.com. Don't forget that many of the same speakers and presentations from our Webinar Wednesday series are featured at our annual trade shows. Our next trade show, the Imaging Expo, will be held next week in Indianapolis. You can still register by visiting theimagingexpo.com. TechNation would like to thank our sponsor, Fluke Biomedical. Fluke Biomedical is the premier global provider of test and measurement equipment and services to the healthcare industry. They serve biomedical engineers, quality assurance technicians, medical physicists, oncologists, radiation safety professionals, and are continually expanding their range of solutions to a broader range of health and safety professionals. Visit flukebiomedical.com to learn more. Our presenter today is Jerry Zion, a renowned veteran in the medical device industry. Jerry Zion has more than 35 years of experience working in many capacities for various medical device manufacturers. Zion has spent the last decade at Fluke Biomedical pioneering the global training program. Zion is an AAMI-certified biomedical equipment technician and holds a Bachelor of Science in Electrical Engineering Technology from Purdue University. Zion also obtained a Master's in Management and Science and Technology from the Oregon Graduate Institute. Jerry, you may begin whenever you are ready.
Thanks so much, and welcome to Advantage Training from Fluke Biomedical. Our topic for this session is 10 best practices for electrosurgery unit testing. Today we'll cover a lot of ground. We're going to start with an overview of why ESU testing matters. We'll be reviewing ESU measurements and how they're conducted. And we'll then transition into global testing standards and how to test to them, how to make sure you're complying with them. And finally, we'll go into the top ESU testing tips as shared with us by some of the industry's top experts. As was mentioned, we encourage you to submit your questions using the text box on the left side of your screen or the right side of your screen. However, our social team is on deck also if you prefer to ask questions via Twitter. Please feel free to do so by tagging us at Fluke Biomedical or by using the hashtag ESUTestTips. In spite of the most vigilant efforts by hospital-based biomedical engineers, third-party service providers, medical device manufacturers, field service engineers, and nurses and doctors using electrosurgery unit generators, incidents and injuries continue to occur each year. Every year we hear and read in the newspapers about burns and surgical fires. There were 550 to 650 patients each year just in the United States. Burns due to reduced dispersive pad contact with the patient's skin. They're hard to monitor because they're underneath all the surgical drapes. Nevertheless, that's a responsibility that the surgical team and the anesthesia team have together to make sure those dispersive pads stay adhered to the skin. Burns due to inappropriate placement of the patient return dispersive pad. That's also a responsibility and a basic part of the training that the nurses and the surgeons go through when they get their electrosurgery units. Electrical shock from either 120, 60 hertz or 50 hertz, or high frequency electrical leakage current, and that's part of what happens in the burn as well. So there's all these risks and incidents every single year that we need to try and reduce. To a great extent, our job is primarily about the medical device itself, and we can't do very much about what happens among the surgical team in the midst of the surgical procedure. But we can do one-on-one trainings, and if you're not involved with your medical staff and nursing staff about in-service training about the medical devices and how to operate them properly, you really ought to be. I really recommend that. It's going to add to your stature and the way that they view you, the confidence they're going to have in you and your department, whether you're stationed at that hospital or whether you're a third-party service provider or a field engineer that's just popping in to visit from time to time. Pay attention to what they need and make sure that they understand their ESUs and their responsibilities. We can't teach them how to practice medicine, but we can sure help make them safe. There are global testing standards relative to the ESU and the ESU generator's performance. And we're going to look at primarily the IEC standards, but I want you to know that the ANSI standards also have been harmonized to these IEC standards. So we're going to call out the IEC standards here. The IEC 61289-2, 1994, high-frequency surgical equipment, Part 2, has to do with the maintenance of high-frequency surgical equipment. The IEC 60601-2-2, 2006, provides particular requirements for the safety of high-frequency surgical equipment. So these are what I'll call minimum performance and safety standards. They technically are voluntary, but if a manufacturer is not adhering to them, they're going to have a hard time getting their FDA clearance to market their ESU here in the United States. And I want you to know that FDA and Joint Commission also have very long arms. They reach out into the international community these days. So anybody, any manufacturer that is providing their equipment or exporting their equipment to the U.S. will find that they'll get visited by the FDA and they will need to be complying with the GMP. So Joint Commission, likewise, for hospitals that voluntarily use them as their accreditation group. Same thing, just like in the United States, they're auditing to the environment of care, which biomedical engineering departments and the medical equipment management plan are all part of. So hospital biomedical engineering and clinical engineering departments and third-party providers generally follow the ESU manufacturer's model-specific inspection and testing procedure. That's found in the service manual for each model of ESU. But we can often look to the IEC standards for guidance as well, just to be sure, or if there's any question. And that's what we do here at Fluke Biomedical when we're trying to make sure that the design of our test equipment is going to adequately test the medical device. We certainly recommend that you do take a look at that. There are some other alternatives if you can't get access to the model-specific inspection procedure. We'll talk about that in a little bit. So armed with an understanding of the potential risks and where the measurement, the requirements for testing come from, let's transition to the top 10 tips for electrical safety, electrosurgery unit preventive maintenance. And it does include electrical safety. So let's start with tip number 1. Always refer to the manufacturer's service manual. Manufacturer recommended test procedures should always be followed. Refer to the service manual for performance of inspection tasks specific to the device. These service manuals typically recommend an inspection frequency. Complete the performance inspection per the manufacturer's procedure. And we're going to talk about a way that you can cross-verify the manufacturer's recommended inspection frequency compared with a risk-based assessment that includes a lot of your own information that hopefully you're archiving and databasing in a CMMS, a computerized maintenance management system, or at least in some way an accessible method of getting to what you actually are using as an inspection procedure, because there's several different kinds. So we'll go into that in a minute. So always follow the manufacturer's service manual procedure if you can get it at all. Tip number 2, adopt a consistent inspection frequency. So whether you're following the manufacturer's inspection frequency or an adjusted inspection frequency that you've come up with using, for example, this risk-based methodology that I'll talk to you about in a minute, you should come up with this frequency of inspection and then stick to it. And then any changes that you need to make to it, you need to make sure you're providing a rationale, a reason why that you're making the change, what changes you're going to make, and how you validated those changes to make sure that you know that they're going to deliver the expected results. And that means keeping the medical device, the ESU in this case, safe and effective for clinical use. So the service manual inspection procedure from the manufacturer is the #1 top choice. But if that's not available, the frequency of inspection must still be determined. You don't get away from it. You have to determine one. One method for doing that is to use a risk-based method, and there's one used by the University of Vermont Biomedical Engineering Department. We teach this in our medical device quality assurance curriculum in Advantage Training. And basically the way it works is this. There are risk criteria that are provided. They're divided into 5 categories: clinical function, physical risk, problem avoidance probability, incident history, and regulatory or manufacturer requirements. The device that we're trying to score and come up with a frequency of inspection is given a score for each of these categories. The scores for each category then are added up to come to a total score, and that total score, we have a scorecard for determining how often it should be inspected. So if the score is 13 or higher, the idea is that you would inspect that medical device twice per year, usually on every 6 months. If the score is 9 to 12, then you'll test that medical device once per year. If the score is 8 or less, you have a choice. You can do biannual, that means every 2 years testing, or you can test during the incoming inspection and post-repair, but not assign any other interval. Now, if you do that, if you make that last choice, you need to, again, write a rationale about why you're only going to test it on incoming inspection and post-repair, and then how you validated that the outcome, that the results of that inspection frequency are going to produce safe and effective performance, and then make sure that that's available for the auditor, because you will be asked. Tip number 3, adopt a formal standardized test procedure. So once again, we prefer, all of us, the inspection procedure from the medical device manufacturer, the model-specific one found in the service manual. But sometimes that's not available. It's still the responsibility to come up, of the biomed department to come up with a standardized test procedure, something you use all the time, year after year, inspection after inspection. It's important that the ESU functionality be quantitatively evaluated, not just qualitatively, by comparing it to the manufacturer's specifications or the requirements in applicable medical device standards. When the medical device manufacturer's specifications are not known, the IEC standard requirements are a reasonable substitute. And if you can't get a hold of the model-specific inspection procedure, then a category-specific test procedure may suffice with the opportunity to add in some model-specific things as you discover them. So the example of that we'll take a look at in just a minute is one that's used by the University of Vermont. And several other of our customers around the world have also adopted those category-specific ones when they cannot obtain the model-specific one from the manufacturer. Once the inspection criteria has been agreed to, no changes should be made without a rationale statement describing why the change was required, what the change is, and how the change was validated. Once again, you need audit trail information. So I don't know that you can necessarily see all of the details, but this comes from our medical device QA program development and procedures textbook that was written by Dr. Toby Clark, who's in charge of the biomedical department at the University of Vermont. And you can get that from us. The tests in this procedure, this category-specific procedure, are physical and visual inspection, regular electrical safety testing, preventive maintenance, including cleaning, and I'll give you a little story about cleaning just in a minute. Performance and calibration verification. So this is going to include operational testing of the ESU's foot switch and the alarms of the device. It will include output power tests based on some number of settings that you select or the manufacturer has described. For those ESUs that include impedance sensing circuits for output power guarantee, those circuits and algorithms need to have a more than one test load value that you're providing that output power to. Otherwise, you can't really tell if those circuits are working. So we would use something called the power distribution test that you'll find on the QAES2, which is our top-of-the-line electrosurgery unit analyzer these days. And what it does is it has a form of onboard test automation in which you choose an output power level, you dial it into the ESU, and then when you start the test, the QAES2 will apply that output power across a series of loads that you select, and you'll get a response from that, and they'll draw a little curve, a little plot of the output power against the load value over time. And you'll be able to see that, hopefully, if you have this output power guarantee, the output power stays kind of on a flat line. It's whatever the output setting was, that's what you should be expecting to see. If for some reason those circuits are not working, the predictable behavior would be that you would begin to see, as the test load increases in resistance, you would expect to see the output power begin to drop off. And if not the output power, you will see either voltage or current drop off, depending on which of those two values or parameters the electrosurgery unit generator design is controlling. So power distribution test really helps us test those circuits. Then we're going to do high frequency leakage tests and return electrode monitor circuit tests, and that includes those circuit alarms, and any other model-specific performance tests that may need to be done. So if you have a question in your mind about the difference between high-frequency leakage and the testing limits versus regular electrical safety, electrical leakage, and those testing limits, we encourage you to dig a little deeper, and there's information online available about that. We don't want to go into that topic too deeply in this particular webinar. So let me give you a little kind of an anecdote about cleaning. In the first hospital in which I worked, even before I had quite finished my associate degree in medical electronics, we were testing older Valley Labs SSE2, Ks, and Ls back in the day. And our hospital, for some reason, just was a lint generator. I mean, there was lint that was all over the place, and the housekeeping staff really did a good job of keeping it all kind of so it wasn't visible. But I'll tell you that anything that has a fan unit in it for cooling also pulls air from the room inside those kinds of devices, and sure enough, those devices are going to fill up with that lint. So you think about it, electrosurgery units have a final power amplifier final stage that requires a huge heat sink in order to dissipate the heat out of that power amplifier. So what we discovered was that the power amplifier final stages were burning out, and we couldn't figure out why, because everything else was normal. The operation in the OR was normal, all the rest of the stuff was normal. And as we began trying to get down to root cause, we decided we would open up one of the electrosurgery units. And when we did, sure enough, we discovered packed tightly all around that final stage amplifier heatsink was this big batch of lint. And that was keeping the heatsink from dissipating the heat, and all the heat went right back into the power amplifier transistors and the circuits, and that's what caused them to overheat and burn out. So we added an inspection step, preventive maintenance. It was called open the ESU and vacuum out all the lint. Why vacuum? Because if you use compressed air and you blow it out, you're liable to blow some of that lint into edge connectors, which are going to short circuit power supplies and so forth, so you don't want to do that. So we use the vacuum. We're very careful about pulling all of the lint out of there. If we needed to use a little brush to help tease some of that out, we did. But we pulled all of that out of there, and that was part of our regular inspection procedure every 6 months on ESUs. And that stopped the burnout of our final stage amplifiers to a huge degree. So including cleaning, whatever steps you need, whether the manufacturer is recommending them or not, you need to be able to respond to how these medical devices are performing and what they're facing in your own facility. Let's go on to tip number 4. Pair additional test equipment with your electrosurgery unit analyzer for comprehensive testing. Now, what we're talking about certainly includes your regular electrical safety analyzer. That's an easy one. So you need that plus your ESU analyzer in order to really do all the testing that you need to do. Don't forget, you should be testing applied parts. So the active electrode, cut and coag, those are all applied parts. Those need to be tested included in your electrical safety leakage current test. Most manufacturer performance inspection procedures require both high frequency leakage and regular leakage current testing. So we're going to do all of that. In addition, you should use an oscilloscope. A medical oscilloscope should be a portable one, so it's easy to carry around, and to look at the actual wave shape of the output energy from the ESU. The waveform output can be compared to pictures that are usually found in the electrosurgery unit service manual, and those waveforms may be found in the calibration part of the procedure for cal adjustment. Whether or not you're going to use the same ESU analyzer for cal adjustments as well as performance verification. But you should be looking at those wave shapes, because the nuances in the wave shape will tell you a huge amount of information qualitatively about whether that ESU is likely to fail during clinical use if you put it back in use after your testing. Your numbers, your numeric values could be perfect, but your wave shape could indicate that you've got some problem with power amplification or things like that. So take a look at that. If the ESU includes an argon gas envelope capability, the gas flow and pressure should also be tested. So you're going to want a gas flow analyzer, and that's the right test instrument to use for that. So you've got at least 3 pieces of test equipment you probably ought to be really seriously considering using, and do a real thorough inspection. You're only going to be looking at these things twice per year. Think about how many surgeries are going to be going on, how much those devices are going to be used in between each inspection, and I think you'll get the idea. Tip number 5, here's an example of hooking up the medical scope meter from Fluke Biomedical to look at those waveform outputs for the output energy. These guys came from Electrolab Medic in El Salvador, and I was just down with them 2 weeks ago. They were pretty adept at using the scope meter and dialing in the trigger so that they had got just 1 or 2 waveforms on the screen, so you could really see the waveform and and whether it was smooth delivery or whether there was some nuance, some problem in the waveform. So that's kind of how that would look. There's an output B and C connector on the front of the QAES, and that's where you hook up your test lead. Now, tip number 5. Be mindful of test leads while you're testing. Keep in mind that we're dealing with radio frequency energy here. High frequency behaves quite differently than low frequency energy. It radiates and induces electrical current flow in addition to any conductive current flow that's going through the test leads when those test leads cross or when those test leads are coiled. So you don't want your test leads to act like antennas. Because I guarantee your measurement values are going to be affected one way or another. So make sure your test leads are draped properly and don't cross each other, and that there is no coils in your test leads. Keep the test lead as short as possible so that it makes it easier to do that. But the test leads are really important to getting this testing right. Tip number 6. Always exercise caution when dealing with active electrodes. Now, I know how most of us are doing testing on electrosurgery units. We jury-rig or improvise connections all the time, and most of us are still using an alligator clip on the end of the single patient use disposable surgical pencil where you can, with a little rocker switch that you can do cut or coag on. So we've got this blade there that's actually where the rubber meets the road during the actual surgery using this generator to actually cut tissue or to coagulate bleeders. You don't want any possibility of anybody touching that blade. We really don't want any of that kind of connection at all. And you don't have to have it that way. You really can these days make the connections without having any of that showing, with no exposed metal that's going to be conductive or heat producing or anything like that. So I've shown you here in this slide a simple illustration that was created by one of our customers in Microsoft Paint, of all things, to show how to hook up for example, an ESU analyzer to the ESU itself, and in order to get the testing right. Now, in this case, there's an internal foot switch in the ESU analyzer so that when you press start, the ESU analyzer itself is what engages the electrosurgery unit and causes it to energize. So you can actually get your testing done very quickly that way. It's not the only way that you provide these hookups. You can do a more simplistic two connection approach and use the ESU's own foot switch. Really, either one of those. Just be sure you're using banana test leads and you're making those connections completely and properly. No exposed metal on your test leads, no exposed metal. You really want to reduce all of that risk to yourself or to your junior technicians. Tip number 7, perform all tests necessary to ensure performance. So we've already listed these before. We're just going to run through them again. Output power tests for sure at several different settings. Usually manufacturers will recommend those in the inspection procedure or in a category-specific procedure. You're going to come up with your own. Whatever ones you're using, always use the same ones every time you go through and do that test. Power distribution test, as I said, mainly for those ESUs with impedance sensing circuits for power output guarantee. You're really going to want to run the power distribution test for those. Or by some means, test the same output energy across several different test loads to make sure that those circuits are keeping that output power where it belongs. High-frequency leakage tests, as well as regular electrical safety tests, and the return electrode monitor alarm circuit. Make sure that you're doing those tests in accordance with how the manufacturer has designed that circuit. What we find is that the Valley Lab RECM tests are a little bit more involved and a little trickier than most of the rest of the ESUs that we find around kind of in the marketplace today. So be sure you're doing that test and that you know how to do that part of the testing. Usually a decade box is a good thing to use, although I know some manufacturers provide a very nice potentiometer, kind of a variable resistor that they recommend you use. Valley Lab doesn't like the variable resistor. They prefer the decade box. So follow the manufacturer's recommendation on that, please. And then gas flow and pressure measurements for those inert gases like argon, and make sure that your flow measurements are correct for that. Make sure you can make those adjustments for gas density if you're using a differential pressure-based measurement. More details on that in a separate webinar. I'll be happy to go into that detail for you. Tip number 8, use test automation to quickly perform tests, document the measurements, and archive the data. So you all know that we have answer test automation software. Aside from the power distribution test in the QAES2, for electrosurgery unit testing, there's no really other real automation of that test besides what's provided by either one of those things. But we would use Answer, hopefully interfaced to the CMMS or database that you're using, and producing, therefore, a single test report that includes everything you've done to do the inspection on the ESU, from visual inspections all the way through output tests, electrical safety tests, your high-frequency leakage, everything that you're doing. Any cleaning that you've done should be included in that workflow. That way, on audit trail, your procedures look really solid, and they will be really solid, and you can match them to the manufacturer's recommended inspection procedure. So make sure you're doing something there. We would prefer you use our stuff, but if you're not, there are other alternatives out there. Just be sure that you're making that workflow, make sure everybody's doing it in the same order, step by step. That makes it statistically sound in terms of your output data, your results, and that's important in order for you to get to predictive maintenance. And I don't know if anyone's talked to you about that before. You want to get to predictive maintenance for those things that fail, not maybe so often, but when they fail, they take a lot of downtime in order to replace or do the repair about. So you want to make sure that you're planning when those things are going to happen. You can't do that without predictive maintenance. In order to get to predictive maintenance, you need to be looking at a long-term trend of parameter measurements and make sure that you understand, based on the design of the medical device, what those results are telling you relative to not only calibration adjustment, but also in terms of wear and tear on the medical device, if you're going to get the entire useful life out of that investment that your hospital made. Number 9 is always archive the test results. So some of us are still using pen and paper and file cabinets with all kinds of test results in them that nobody is then going back and looking at all. So no long-term trend, because nobody cares after the job is done. But that's not the end game for biomedical engineers and medical device QA. The end game is what I said just a few minutes ago. So some way or another, we need to make sure that we're at least appending the automated test result reports to the CMMS work order, whether or not the interface to our automated system allows that work order to be automatically closed on the strength of an overall pass of the medical device. There's a lot of efficiencies that can be built in here, but the bottom line is make sure those test results are attached to that work order and that you can see what they are, and that somebody's looking at the longer term trend one way or another. Tip number 10, return the ESU generator settings to the settings preferred by the clinical unit staff, that is the doctors and the nurses, before returning the device to clinical use. And some of you have been burned by this one already. Invariably, when I bring this subject up, no matter whether it's ESUs or patient monitors or whatever it is, everybody has a story. So someday we're going to have a beer and I'd like to hear your stories, but for right now, be sure that you're documenting what those ESU generators, either what they were set to when you found them and brought them to the shop or wherever you're doing the testing, or else an agreed to set of settings that are expected for that device by the surgery department staff in this case. Do yourself a favor. They'll have better confidence in you if you do a nice little professional job here like this of returning them to the settings they expect versus making them guess or making them make a mistake that hurts the patient. Because if you expected the output power to be 0 and the output power was 300 watts, guess what? You just burned the patient and you didn't mean to. So pay attention to this because it's really pretty important. So we said 10, but how about a bonus tip? Bonus tip is this. You can download a free white paper, and for those of you that downloaded the workbook for this webinar, that white paper was included in the workbook and some extra sheets of paper for you to be able to make your notes on. So we highly recommend that you do that and take a read through. We're told by TechNation that they're recording this session so that you could go back and listen to it again if you need to for any of the topics that we've talked about. So if you have any questions, you can send them to us, especially if they're about electrosurgery unit generators, especially ours. You can send that question to sales@flukebiomedical.com or call the toll-free numbers. Or you can take advantage of our Advantage Training Center. It does require a login for you to get a registration for you to get login credentials these days, but all of the training has now been organized into courses, and all of those courses are for free for you to self-serve and for you to complete in your own time. There are quizzes to help you solidify your learning, and when you pass those quizzes, the system automatically generates your certificate of completion. So we encourage you to go in and spend a little bit more time with training about all different kinds of medical device testing, and it's available to you on our website. You can connect with us also through social media on Facebook or Twitter, LinkedIn. You can see our videos on YouTube, and you can get to us also on Google+. So we really thank you for your time on this webinar. We hope we've shared some information that's useful and of value to you, and we We love your feedback. Good or bad, please send it in to us so that we can improve whatever the training or webinars are that we're doing and providing to you. And that includes ideas for some topics we haven't covered. So make sure that we understand what you need. Thanks again.
Excellent. Thank you so much, Jerry. We do have a few questions that have come in, but I do want to remind the audience that you can still submit questions throughout even this portion. We are checking those and we'll address those as they come in. In the meantime, the first question that came in, Jerry, is can Fluke's QA-ES test force triads and force FXs?
Indeed, it can. The Valley Lab prefers that you do not use QA-ES2 for calibration adjustment. However, for performance testing, there is no reason why you cannot. Everything will work. You'll get your measurement values, and it all works well.
Excellent. Okay. The next one that came in is, can I use answer test automation with the QA-ES?
Absolutely. QA-ES has an answer plugin, which means that we've taken care of the device driver and answer the template that you create, or if you're using a category-specific template that we've already created and provided to you in the answer test library with the software, actually reaches out, configures QA-ES2, and collects the measurement values automatically for you. In fact, you can even use that, the answer test procedure, that template, can include everything that you're doing. So all of the workflow can be included. And if you have an answer plugin for any of our safety analyzers, you can also incorporate that into your workflow. So all of your measurement values can be pulled in automatically, including those ones for argon gas, by the way, if you're using any of our 3 gas flow analyzers.
Wonderful. Okay, the next question. Does the QA-ES test ligature?
This is kind of an interesting question. And I asked this question of Valley Lab folks myself because I was a little concerned because ligature, when you're doing the calibration adjustments for it, wants test load values of 10 ohms and some lower. And of course, QA-ES2, the smallest test load that we have is 10 ohms. I mean 20 ohms. So that kind of makes you think that it can't do it. But indeed it does, because here's what Valley Lab says in the service manual for ligature. They say, if bipolar, cut, and coag are within tolerance, ligature is within tolerance, and there's really no test. So my answer to this is, yes, of course it does, based on the information from the manufacturer of models of ESUs that include ligature.
Wonderful. Okay, here's another one. Where can I get a copy of the manufacturer's service manual?
So the first and best place to start is the manufacturer of the medical device. You should expect that they're going to want you to pay for the service manual. They run all different kinds of prices, but get them from the manufacturer. They may want you to go through their service school for each of the models of medical device that they make. That's fine. You're going to be well advised for someone in your department at least to have gone through that. We had really good luck requiring one copy of the service manual with each order of medical devices that we made when I was directing biomedical engineering departments in the hospital. We made that a requirement of the purchase order and the purchase agreement. So in other words, we're not buying your medical device if you're not going to give us one copy of the service manual. Oh, and by the way, one of our technicians or engineers to go through the service school also for free. So we did a pretty hard negotiation on that. We were successful 99% of the time. And when, for example, you can't get it, or maybe the medical device is too old and the manufacturer is not really providing those service manuals anymore, try Frank's Biomed Shop. That's online. He's got some agreements with some of the manufacturers and has archived some copies of service manuals for all different kinds of medical devices and models. I've had really good luck there myself when I really need to dig a little deeper into how a medical device is designed and what its theory of operation is. But you can try those two places. I strongly recommend you get it from the manufacturer if you can. That's the best source.
Wonderful. Okay, another question that came in. How often should I inspect an electrosurgical DUT?
So we kind of went over that in the webinar, and we identified that of the top 5 manufacturers of ESU worldwide, they're all recommending twice per year inspections for performance testing and preventive maintenance. But that was nicely cross-checked using the risk-based assessment criteria that University of Vermont uses. It's not the only way to cross-check that frequency of inspection, but it's a way. It happens to be the way that we teach. So you could do it either way and come up with the same result, which is really satisfying and confidence building.
Fantastic. Okay, here's another question for you. What equipment do you recommend besides an electrosurgical analyzer when testing an electrosurgical device?
So electrical safety tester for sure. And then we also, as you saw in the webinar, these days are recommending a good oscilloscope. You could use a Fluke scope meter, 190M, which we also provide. But truth be known, as long as the frequency response of that oscilloscope is appropriate, you could use any oscilloscope. The scope meter tends to be a bit easier to use because of some functionality that have been designed into it. But you could use any one, and I recommend that you do that. In addition, if the electrosurgery unit has that inert gas like argon gas envelope, you should be testing the gas flow and pressure. So a good medical gas flow and pressure analyzer like we also provide.
Excellent. Okay, another question for you. What are the major tests you perform when testing an electrosurgical device?
Okay, so the major tests are going to be all your visual inspections and cleaning. Then you're going to be doing output power tests. You're going to be doing a power distribution test when the electrosurgery unit includes any kind of power guarantee circuitry in it. You'll be doing, so in your output power test, you're going to test in all modes. So you're going to test in cut and coag, and in all of the different variations of blended cuts, as well as the fulguration, as well as spray on coagulation. So whatever modes are on that ESU, you should be doing the tests for during the output power test. Then in addition, you're going to do high-frequency leakage tests and regular electrical safety testing, and make sure that you're doing the RECM, the return electrode monitor circuit tests, according to the manufacturer's instructions.
Fantastic. Okay, here's another question that came in. What are you talking about when an electrical microshock hazard from HF leakage?
Can you repeat that question, please?
Yes. What are you talking about when you say an electrical microshock hazard from HF leakage?
Okay, so let's talk about the difference between microshock and macroshock, and I'm going to keep it real simple for you. A macroshock is a shock you can feel. A microshock is a shock that you receive that you don't feel. And there is that is an actual real thing, microshock. Microshock is what happens to a patient with an indwelling catheter when they get connected to the protective earth ground or the reference to the isolated power. And the current flow happens down the conductive wires that are now going through that indwelling catheter right to their heart. That microshock is able to kill the patient. So microshock is a shock you cannot feel, whether or not it's delivered to a vital organ that could be damaged by it. So there is electrical current flow even DC. It doesn't have to be AC, alternating current, it could be DC. If you touch a battery and you touch another wire that connects to the other side of that battery, you're going to have electrical current flow through you, even if you're not feeling it. And typically, the way that your anatomy and your physiology is designed, the electrical current flow is shunted around, away from or around your heart in your chest cavity, not through your heart, but it can flow through your heart. So that's really the difference between microshock and macroshock, and it happens both for regular electrical leakage as well as high-frequency leakage. The difference is the high-frequency leakage is usually at a frequency higher than and not a harmonic of the power line frequency. So power line is 60 hertz in the United States, 50 hertz everywhere else, and that's very close to the human normal heart rate of around 60 beats a minute. That is high risk electrical leakage in that frequency range. But at higher frequencies that are not harmonics of the 50 or 60 hertz, you also have electrical leakage current that happens, and the acceptable testing limits for those is a much higher value. In fact, in the regular leakage current, we're measuring in microamperes of current flow. In high frequency leakage, we're measuring in milliamperes, so there's an order of magnitude, several orders of magnitude more allowable current flow there than there would be at the lower frequency, because it's not happening at anything close to our heartbeat, our heart rate, or a harmonic of our heart rate.
Fantastic. Okay, another question. Is it necessary to apply stickers to the device that show the output values during your testing?
So that's a real good question, and that's actually an audit trail question. I always did, but the reason wasn't so much audit trail as it was the request of the clinicians, the surgeon and the surgical nurses and the supervisor from the OR. They wanted to know and be satisfied that for whatever the setting was on the ESU, that our measured output was within the acceptable limits, and those stickers helped them realize that. So beyond audit trail, it was just a good communications and the response to a request from our clinical unit.
Excellent. Okay, here's another one that came in. What about Crest Factors? Do we need to test and record this reading?
Yeah, a good electrosurgery unit analyzer is going to report the Crest Factor. There is other training that we have that's available that identifies what in fact is a Crest Factor. What does that mean? What's the math around getting to a Crest Factor? I'm not going to go into it right now, but that's available, and certainly there are a lot of places that you can find that information, that definition of what is Crest Factor. But a good electrosurgery unit analyzer is going to provide that for you. It will read out the Crest Factor.
Very good. Okay, here's another one that came in. Can the QAES test CONMED's hypercator 2000?
The QAES can test hypercators for sure. Sometimes the testing load that's wanted is, again, a low resistance value, and the Crest Factor can be kind of high. Generally, we can do those tests. I haven't seen one so far that we could not. That doesn't mean that there isn't one. So double check the specifications for QAES against the expected values for the measurements that you want to do for those hypercators, and that will really tell the story. That's really what we end up doing in tech support if we're trying to help you answer that question in specific ways for specific models. So I don't necessarily have the answer to that in a very specific way right here, right now, but we can help you with that probably.
Excellent. Okay, here's another one, Jerry. You say applied parts need also to be tested. This makes sense. But how does this practice apply to disposable electrosurgical probe tips? What is your view and recommendation?
Okay, so single patient use disposable means I ain't testing it. Doesn't need it. The single patient use disposable things are not really intended to be opened until you're going to actually use them with the patient. And once you're done using them with a patient, they need to be thrown away. They're just exactly as they're defined. And from a FDA point of view, that's exactly what's expected. I know in many parts of the world, single patient use disposable items are cleaned and reused, and that's risky, which means at that point, if that's what your hospital's decided to do, you better be testing them before you make them disinfected or cleaned or sterile and repackage them for the next use. It's going to be a limited number of times you can use them before they break down and fail anyway, I'm telling you. They're just really only designed for single patient use. So no, we would not test that, but we still need to know when let's say when we connect a reusable active electrode for cutter coag, now what happens, how much current flow, leakage current flow could happen in the parts of that connect directly to the patient. We need to know the answers to those what ifs. What if the mains, line 2 opens? What if the protective earth ground opens? So we have to have all of those answers to those what ifs relative to electrical safety when we're running those tests. It's just as applicable to an ESU as it is to a patient monitor or defibrillator with pacer leads or anything like that. So what I use is a set of test leads, and I just run that test, and whatever leakage current is flowing down my test leads, we assume is going to be the amount of leakage current that's going to be available should something happen and we're actually using the single patient use disposable in its place.
Very good. Okay, another question came in. Can you give a simple way to test the high frequency leakage?
The simple way? You need to use your electrosurgery unit analyzer. It's designed with the right test instrument for a current meter to be able to make that measurement. And you need to make the connection as described. So I'll be happy to provide the connections for QAES to anybody who wants them, though simplistic they are, that they will help make sure that you can get a complete circuit so that your testing is effective. A lot of the problem that we have with ESU unit testing is we don't know how to hook the wires up, the test leads up, so we have a complete circuit. If you don't have a complete circuit, you will not energize the ESU and you will not get the right value. Sometimes you won't get any value. So you may email us, just email us, and I'll be happy to send out those illustrations.
Fantastic, thank you. Okay, another question came in. Valley Lab manufacturer claims that the output test must be measured in amps. QAES limits are in watts. Can limits be measured in amps?
No, my friend is mistaken when he's, well, let me say this. His answer is incomplete. QAES provides for each measurement, that if each energization and output energy measurement, not only the output power in watts, but the voltage and the current flow and the Crest factor, every single measurement. So it would be a misnomer, a mistake to think that QAES only provides the output energy in watts. It provides everything that you need to make those tests.
Fantastic. And Jerry, this is the last question we're going to have time to get to today, but we will send you all of the questions that have been submitted so that you can follow up with those remaining.
Super.
And bear with me, I may mess up this unit of measurement. So the question is, we have several manufacturers that have non-standard loads for their performance tests. Can the Fluke tester meet these loads? For example, 5, 20, 68, ohms?
So the 68 ohms would be difficult to measure, and sometimes we can't get exactly the load and the non-standard loads. I understand what he's meaning by that. So typically what I do in that situation, because we're not the only ones that are going to have a problem with that, I know that there's a couple of models of ESU analyzer out there that are using external loads, and one would think that therefore I can mix and match and come up with any value that I need to. But I want you to remember that those are the external resistance values, and the actual resistors themselves, the loads themselves, are a very precise load. They are not just off-the-shelf resistors. So don't think that you can just build your own load from off-the-shelf stuff. You need to make sure they're precise and they're conforming to the requirements for the test device. And I will say as laid down in the standard, okay? Because that's always where we're going to look back to. The testing methodology and procedures really come originally from the standards. I get as close as I can, and I make the measurement, and if I have any concern, I get a hold of the manufacturer of that particular ESU model and do a little consulting with them, because if they've picked a really non-standard load value, that means they're trying to control you and your spending and require you to buy extra test devices just to test electrosurgery unit generators as a category. There isn't any reason why they should do that. The standards, the requirements laid down by the standards are sufficient to make sure that these medical devices are safe and effective for clinical use. Anything else is a power play. So don't get taken.
Fantastic. Thank you so much, Jerry, and thank you again to today's sponsor, Fluke Biomedical. Please visit their website, flukebiomedical.com, to learn more about their products and services. Attendees, remember to complete your certificate of attendance. You must complete the post-webinar survey. It should appear immediately on your computer screen. If you don't receive the survey, you can email us at webinar@mdpublishing.com. Please visit